In fractions, as you know, no matter what kind of fraction it is, we have to have a common denominator. So the first thing I'm going to do is I'm going to start by giving you some fractions that already have a common denominator. They will have variables and exponents and binomials, but to start with, we'll practice with some that already have the same denominator. 3c over 16 plus 5c over 16. If they already have a common denominator, remember that when we add and subtract, that denominator doesn't change. We're just counting how many 16ths do we have. So we keep our denominator the same, and we either add or subtract according to the sign our numerators. So 3c plus 5c makes 8c. Now we need to always simplify our answer whenever possible. Can I simplify this? Yes. Remember that we can simplify when things are being multiplied. It's when they're being added and subtracted that we have to be extra careful. But there's no plus or minus here, so I could simplify 8 and 16, both divide by 8, which leaves a 1 and a 2. 1c, I'm just going to write that as c, you can keep the 1 if you prefer, over 2 is our final answer. So this kind of combines some of those ideas of simplifying these fractions that we've done in earlier parts of the chapter. Not too bad, right? Okay, let's make it one step harder by throwing in some subtraction. And I'll show you why I say that it's harder. Normally it's not much different. 5x plus 4 over 10 minus 3x minus 8 over 10. So again, we're starting with the same denominator, so we're not going to change anything just yet. We're going to save that part for later. Now, here's why this is trickier. Because this fraction, the numerator that we're going to be adding and subtracting, in this case it's subtracting, this is a binomial. So we have to be careful that this minus is minus the entire second numerator. So I'm going to suggest that it might be helpful for you to put parentheses around it because it's minus the whole thing. And then think about what we did when we added and subtracted polynomials back in chapter 4, I think it was. And we said, hey, when we're subtracting the second one, let's change it to adding the opposite. Because it's minus a 3x. And almost everybody will get that, minus 3x. But then the part people forget is it's also minus negative 8, and that makes it a positive. So let's say that when we're subtracting a binomial, we're going to change it to adding the opposite. And if you change all the signs to their opposite, now you won't have as much to remember when you start going across the numerator. So first I'm just going to go across and write down what I have. I have 5x plus 4. This has now become a plus, so plus negative 3x, so I'm just going to keep it like that. Plus a positive 8, well we can just say plus 8. Now I need to simplify the like terms. The denominator is just plain old 10. But in my numerator, there are some like terms that I could combine. 5x plus a negative 3x. Well, 5 minus 3, or 5 plus negative 3 makes 2x. And then I've got the plus 4 and the plus 8. And of course that makes 12. And we're almost done. We're not quite done with this one. This is combining a bunch of stuff. So although the denominator doesn't need to change, there's a lot of other little things to think about. Here's what I need you to think of when you think you have the answer. Can I factor any part of this? Can, I'm not going to worry about. What about the numerator? Can I factor something, Vincent? I can factor a 2 out. And here's why I need to do that. Because I'm going to be able to simplify more. If I factor a 2 out of that numerator, that 2 is being multiplied by the x plus 6. Because it's being multiplied, I can simplify it with the denominator. So the 2 and the 10 have a common factor of 2. So now that I've factored out this 2 and it's being multiplied, now I can simplify. I can't do it here when it's a 2. I have to have it being multiplied. So if I factor it out, divide by 2, divide by 2. Now again, we don't need that 1. We could say 1 times x plus 6, but of course that's just x plus 6 with or without the parentheses, and my new denominator is 5. So if you can factor your answer, please try to do so, because if you can and it simplifies, then you need to be able to get to that simplified answer. Questions on that one? Okay, just 2 more. I'm sorry, just 1 more. Take it back, even better. Even better. Just 1 more for today. Oh, no, I'm sorry. I was right the first time.
Oh.
I'm sorry. Not trying to psych you out, but I just want to make sure we have everything done. Okay, next example. Now, you're going to see some where there is a slight difference in the denominator. We need to have the same denominator. This one, they're not quite the same. 2 over x minus 3 plus 7 over 3 minus x. Are these denominators exact opposites? Good, I see thumbs up, right? Positive x, negative 3, positive 3. When I have exact opposites, in order to make them the same, because I need to have a common denominator, I'm going to do my -1 trick. So I multiply it times -1. Now remember that what that does is it just flips all those signs so that it becomes the same. Now I reordered them also. The x becomes positive, the 3 becomes negative. I just put it in the same order so that you can see that these denominators are the same. But remember that it also makes a negative. So if I multiplied this and this whole second thing became negative, it got my denominator to match, but it also made a negative. So you could say plus -7, or you could change the plus and you could say -7. It's the same idea. But don't forget that that whole, whatever you do the negative on, that whole thing becomes a negative. So now my denominator is the same, x minus 3, with or without parentheses. It doesn't matter either way. But now because of that negative, 2 plus -7, or it would be 2 minus 7, either way, is -5. Now I have the negative up here. You could have it in the numerator. Remember, you can also have it out front, or you could have it outside the parentheses in the denominator. As long as there's only one, it can go anywhere you like. Numerator, out front, or denominator. Okay, so just watch out for the -1 trick. Last example,
I
yes?
have a parent on the phone wants to know, is there a running club today? It's canceled, right?
No, we just canceled it.
Okay, thank you.
Okay, final example. The bad news is you have to find a common denominator. The good news is I'm only going to give you plain old numbers for today. We're going to save the trinomials and binomial denominators for tomorrow. So, a over 4 is our first fraction, minus 5 plus 12a over 18. So again, we're going to have to find a common denominator, but for today, just numbers. Old school, plain old number, common denominator. Okay? So, remember that in order to do this, we have to also change each fraction into its equivalent fraction with my new common denominator. So first of all, what do you think the LCD should be for 4 and 18? Brian? Good. Again, start with your biggest number. If you have trouble, 18, start listing multiples. 18, that doesn't work for 4. 36, oh yeah, that works for 4. There it is. The next step is to take each fraction, and this was like those last 2 problems from yesterday, the 36 and 38. We have to turn them into their equivalent fractions that now use our LCD. So using the denominator of 36, now here's why this shouldn't be too hard, although the numerators have binomials and variables, the denominator is just like before, right? Just plain numbers. So 4 times 9 makes 36. So a times 9 makes 9a. On my second fraction from 18 to 36, well, of course, that's times 2. And be careful on this, guys. Times 2 on the numerator, it's times the 2 times the entire thing. And I'm going to suggest we're going to go ahead and distribute that 2 to help us simplify later. So instead of just writing 2 times this whole thing, I'm going to use the distributive property. 2 times 5 is 10, and 2 times 12a is 24a. Because we're going to have to add and subtract these all together, which means we need to simplify them, so we might as well just do it here. Almost done, I promise. Now, because this is subtraction, I'm going to rewrite my new fractions, these 2, because remember, I need to subtract this whole thing. If you think you can do it without rewriting it, just be very careful that you don't miss the minus. 9a over 36 minus 10 plus 24a over 36. Because it's subtraction, and because it's subtracting a binomial, we want to make sure we subtract the entire second binomial, the entire second numerator. So let's go ahead and add the opposite. I'll change subtraction to addition, and I will flip all my signs. My denominator stays 36. First thing I'm going to do is I'm just going to write down everything I have into one fraction. I've got 9a plus negative 10. You can keep that as plus negative 10, or you could write minus 10. It's the same. Plus negative 24a. Again, you could say minus 24a, or plus a negative. Almost done, I promise. Like terms. 9a plus a negative or minus 24a. 9 minus 24, negative 15a. Plus negative 10, or you could just say minus 10. Plus a negative is also correct. Now, let's try to visualize what would happen if we factored this numerator. I'll tell you right now, you can leave this answer like this if you want. This one, because if we were to factor it, think about what we could factor, like we did on that last one. Think about that we could factor a 5 out, or maybe even a negative 5. So if you don't want to write this down, you can just watch. If I factor a 5 or even a negative 5, if I want to take that negative out with it, oops, and then this would be a plus. Do 5 and 36 do anything? Can I cancel anything there? No, they don't have any common factors except for 1, which won't make a difference. If you can look at this and go, oh, if I factor out a 5, oh wait, that 5 out front won't do anything with 36, I'm not even going to bother. If you can visualize that it won't simplify, you can stop here. If you can't visualize it, you need to factor out this 5 to make sure, and I would accept this answer also. If it simplifies, if this 5 and 36, let's say it was 5 and 35, if they simplified, you have to do that. If they don't simplify, you can leave it back in the unfactored form, or you can factor it and go, oh, it doesn't simplify, oh well, I'm still done. Okay, so that's it for today. I know, that's all. Right.